Welcome back to Longevity Roadmap. This is Buck Joffrey, and today's guest is Dr. Marta Yanina Pepino. She's an associate professor of the University of Illinois, specializing in digestive behavior and nutritional sciences. She earned her PhD in chemistry from the National University of Cordoba, Argentina, then completed postdoctoral research at the Monell Center in Philadelphia. Her groundbreaking work on taste, perception, food preferences, and digestive behavior, particularly in relation to obesity and addiction, earned her the Moskowitz-Jacobs Award in 2011. Her research continues to advance our understanding of how individual differences impact eating behaviors and nutritional outcomes. Welcome, Dr. Pepino. How are you?
Welcome, and thank you so much for this opportunity. I'm very excited to be here.
Thank you. We love having you. Well, why don't we start out with this? Why don't you tell us a little bit about your journey into research on taste perception, really unique place to land, right? And specifically taste perception as it relates to metabolic health.
That's right. So I am from Argentina. I did a PhD on trying to understand how we may like the things that are exposed in utero. And we talk about flavors. And in particularly, I was interested in the exposure to ethanol or alcohol when a mother drinks during breastfeeding or during pregnancy, and how maybe those cues of the smell and flavor of alcohol can be started to be learned by early on, since a baby or since you are a fetus, and then generalized to preferences for alcohol. And so I work a lot about alcohol and lactation and understanding preferences that you can learn. That's how we learn in part about our flavor preferences for food. So a lot of the flavor that is transmitted to the mother's milk, and babies are starting to learn what is safe and what should be eaten when they start eating in the table food. And that kind of allowed me to get to the United States to do a postdoctoral study at Monell Chemical Senses Center. So I had the pleasure to work with Dr. Julie Menela, and she was one of the only women working in the transfer of alcohol to mother's milk in women. And so by being in this center of Monell, that I was interested first in alcohol, I started learning a lot about all kinds of flavors and different things that travel through mother's milk. And then I expand in understanding how children perceive the different tastes. It's quite different than adults. What happened with adults with obesity or with adults who smoke. And so I started understanding, trying to understand more of the individual differences in our sensory perceptions and how they influence our food preferences and our ingestive behavior.
Fascinating stuff. And I guess, my question, the way I'd like to start is to really ask you about how individual variability in taste perception influences the risk of obesity or metabolic syndrome, or metabolic disorders in general.
Well, although very neglected, the sense of taste and smell, neglected in the fact of that we would like to have more research in these senses, and people sometimes take them for granted. We talk a lot about audition and vision. There is a lot of research and funding, but when COVID hits and let us all without the sense of smell, or many of us without the sense of smell and taste, we start realizing how important it is for coordinating digestion, for our life, for our pleasure, for our food preferences, and so on, including our risk for disease such as obesity or metabolic risk. And so when people have differences, so taste perception is critical to coordinate digestion, for example, and cephalic responses, how you're going to absorb nutrients, how you're going to handle the food that you're consuming. And so we start trying to look how individual differences, so for example, people who are less sensitive to detect fats, or people who are more sensitive to detect bitter, how those things play a role in later preferences. And for example, we know that if you are more likely to perceive a lot of bitterness, very sensitive to the intensity of different bitters. There are in particularly some bitters that are due to the genetics. For example, if you think on the bitterness of like broccoli, spinach, and some of the green leafy vegetables, depending on a particular gene that we have on a particular taste receptor for bitterness, can make you from blind to that bitter taste or exquisitely sensitive.
Right.
And those things is to play a role not only on how children will react and start eating different vegetables, but even other things such as maybe smoking or protecting you for the bitterness of alcohol, making fine alcohol less palatable at the very first time that you drink it. So you can see how individual differences in the genetics already on those taste receptors may change how you respond to foods.
One of the things that you mentioned early that I want to just kind of follow up on is you mentioned that when people were losing their sense of smell, and obviously smell and taste are one and the same essentially, but they were having changes in digestion. So can you explain sort of this relationship? I think you mentioned that, when you taste or smell something, you're sort of preparing your digestive system for those kinds of macronutrients. I think that's something that I certainly didn't know. Can you talk a little bit about that?
Sure. So one of the things like coordinating how we're going to handle what we're going to ingest. So one important task for the brain is to try to predict what is going to happen next and try to maintain homeostasis. So eating can be pretty stressful for the brain because it's a big change. Once you imagine a meal, your glucose will start going up and different nutrients will get in. So how can we predict what will be the impact of what you are eating to decrease the challenge from changing all the parameters that you need to keep in homeostasis? So, for example, very elegant research from Dr. Karen Teff when she was at Monell Center was looking at the impact of precisely what you asked, the taste perception, and for example, in how you handle glucose when glucose is being absorbed from the stomach, the intestine, and also how you're going to respond to that glucose with insulin, how sensitive you're going to be to absorbing that glucose and making it available for all the cells in your body. And what she showed is that, for example, if you take a tubing and you infuse directly glucose in the stomach, right?
Mm-hmm.
On one day, you just infuse the glucose. You don't give any information to the participant on what is going on. On another day, to the same participant, as you are infusing the glucose in the stomach, you allow them to chew some food. So you give them it's called sham feeding. So they're going to be chewing food and then spitting it out.
Yeah.
But it's just giving the brain the idea that nutrients are coming. And when they do that, it was remarkable how there was a much better response to the glucose. It was handled in a better way. Glucose concentrations were coming back to baseline sooner. And so it was
they were coming back to balance sooner when they perceive sweetness. So sorry to interrupt you, but it brings up a really maybe an interesting question. What happened with the insulin response? Because obviously the question that you've probably thought of, and I'm sure somebody has thought of, is, okay, well, what about sugar substitutes then? Are we spiking our blood sugar, or are we releasing insulin in response to something that's not actually supposed to do that?
Great question, and one that we've been looking at, like many other labs in the world have been trying to understand this important question. And so it's kind of complicated. What we know so far is that what you're tasting in the mouth is already informing the brain on what are the nutrients that are going to reach the gut and how they should be handled. And so it seems that the sugars and the low-calorie sweeteners, they are all activating our sweet taste receptor. And they use different ligand points, different parts of the receptor, kind of like different lockers of the key to get in and send the signal that is sweet. And we think that this is important for regulating insulin, but particularly when you think on glucose, it has different ways of activating this sweet taste response that release the cephalic insulin response than low-calorie sweeteners. And so it is interesting that perhaps you can come up with a very good solution of two sweeteners, one with a low-calorie sweetener and one with sugars, that for us is difficult to say which one has calories and which one does not, like if I ask you objectively to taste and say. But the brain, very quickly, when you swallow that, the brain in kind of like minutes will respond differently. So that was something that we were puzzled about and not understanding is that it's one sweet taste receptor. And you cannot tell me, you cannot trick your tongue very easily sometimes, depending how you prepare the solution. How come the brain knows? And then research by Diego Bojorquez at Duke show this very fascinating concept that a new discovery that there are some cells, endocrine cells in the gut that use sweet taste receptors, and they are activated by these nutrients in the gut, but in milliseconds by vagal connections. So these are like making synapses, can tell the brain whether what you have in the stomach has calories or not, whether it's a sugar with a sweet taste with calories or a sweet taste without calories, because they start a different cascade of events. Although they both activate sweet taste receptor, glucose seems to have also other receptors that they can activate in addition to the sweet taste receptor, and ended up in a cascade of events that tell the brain that what you have is sugar and is different than the low-calorie sweetener.
Yeah.
So to make the whole complete story, because you asked what happened with the insulin response. It seems that the insulin response is a more robust release of insulin, and it's been measured in humans. You cannot even measure the cephalic insulin response very reliable in people. You measure it only when you give them sugars that have like a calories attached. And so it seems that we are evolutionary. There are many layers, and it's a very smart system to tell you that it's not just relying on the sweet taste response in the tongue. There are also other things that are being activated in addition to the sweet taste receptor to promote that you're getting calories from sugar and that you should start preparing by releasing a little bit of insulin. And that's what happens when people receive sugar with a tube and they can chew on food that have a sweet taste. There is a tiny bit of insulin that is released that you don't see when you don't have the cues of chewing something. And that tiny release is very helpful to predict how much insulin will be released later and how sensitive you are to that insulin. And so if you can give the body the cues that the nutrients are coming, they are more effective in how they release that insulin and how sensitive they are. That if you just go blank and send that glucose directly in the stomach, then insulin will have like a later but higher peak. And so, it is a very complicated system, but it's very nicely coordinating.
But I guess the moral of the story is, some of the sugar substitutes like stevia and all that, they're not triggering a systemic response. And so they are doing what they're supposed to be doing, which is providing this ability to taste something sweet without necessarily triggering anything else systemically. Because the body, as you mentioned, these receptors in the gastrointestinal system within seconds are noting whether or not that is actually glucose or something else sweet without calories. So it is effective, right?
It is complicated too. I wish it was that simple that it's only one layer, because these sweet taste receptors these sweet low-calorie sweeteners that have no calories attached to it, they may not be disguising the stomach, and so there will be different cascade of events, but they are also sending some signaling to the brain saying there is a sweet taste in the stomach. So I agree they are doing different things than the real sugar, but it doesn't mean that they have zero consequence physiologically.
I mean, that's why I specifically asked the question in framing it with insulin, because, with metabolic disorder, obviously hyperinsulinemia is the major thing that you're trying to avoid. And if you are releasing insulin in response to sugar substitutes, that's not going to be good. It's not going to be good for a diabetic who's trying to avoid it.
The thing is that it is also make it complicated because we typically don't consume one thing and one only at a time.
Yeah.
And so maybe it's very different, the results you get in a study. If you only give them an artificial sweetener to drink or like a diet soda in itself, then you will not see differences, most likely, in their insulin responses. You will not see differences in insulin sensitivity or other metabolic outcomes that are, that we typically measure in these metabolic studies. However, the outcome may be different when you combine a low-calorie sweetener with some carbs or with some sugars. So when you drink a diet soda in combination with some other food, like with a burger, with a pizza, with a cookie or whatever, now you're mixing it up, and then you need to think on those receptors in the stomach, in the intestine. They will be activated by different substances. And some of them maybe, what we know also is that, for example, the sweet taste receptor, when it's activated, it will upregulate the disposition of other glucose transporters. So if you're mixing, for example, a low-calorie sweetener and a meal with carbs, now that non-caloric sweetener perhaps could have some physiological effect, but just by activating the simple sweet taste, even if it's saying it has no calories, it will upregulate other receptors that can make the absorption of that carb that you had together with the diet soda to absorb those carbs faster, which will change the way that you release insulin, because insulin is very sensitive on the slope of how sensitive you are, how quickly that glucose is raising up. So the rate of glucose absorption in the intestine will modify the pattern of insulin response.
Right.
And so in that case, the result of the study will be very different if you ask, do low-calorie sweeteners change how we respond to a carb? That if you said, do low-calorie sweeteners alone in itself change at all insulin responses or glucose responses?
Right. So getting back to, I guess, nature's true sweetener, it's glucose or other macronutrients, fats, proteins. What does nature versus nurture play in shaping our taste preferences? In other words, are these genetic? Are they culturally impacted? What creates a bigger impact, in your opinion, in terms of, what people taste or their taste preferences?
I love the question. And the answer is typically that is a little bit of a mix of both, nature and nurture. There is a basic setup, which you are born and you come, and those are like the sensor, like your kitchen, with what are you equipped to perceive. And so, of course, that you have some SNPs that make you perceive less intensity of sweetness or more intensity of bitterness, and those things will start shaping and modulating how you will respond, at least initially, to the food.
Yeah.
However, I will say that overall, because as you are developing and with aging, I think that learning, nurture, had a lot to do, because you had to think that every meal is a new opportunity for the brain to learn what are the consequences of the ingestive behavior. Whatever you're eating, how it make you feel, how much sugar, the rush in sugar, the availability of energy or not. And so the brain will code each event when you're eating and make a note on how you feel when you ate that food. And so as we grow and as we have experience of what we eat, we start developing preferences, condition to those by association to those things that you ate and what happened post-ingestively. Because there are, for example, very interesting studies, we will go to some animal models because it's easier to look at these questions. If you take an animal that is totally blind to sweetness, right? They have a knockout, they knock down their sweet taste receptor. If you give them sugar versus water, initially they drink the same amount from both bottles because they don't know. They don't have an innate preference. That genetic is kind of deleted, if you will. However, if you give them some time to experience this and learn the position of the tubing and how they feel when they drink, they very quickly will learn a preference to the one containing sugar.
Sure.
And so it's through the post-ingestive effect that they are now associating, this tube located here, or if you give them a sound or you give them a flavor added to this that is not sweet, they will learn a preference to those nutrients, to those infusions that give them nutrients. Particularly glucose is the queen. Particularly, we are kind of really hardwired to go for glucose, the cheapest of all the fuels for the brain.
What about in children? Like, when does this develop, I guess? And it makes me think about, I have 3 girls, and one of them who's 12 now, but when she was 1 or 2, and she would eat anything, and she seemed to like everything. And then, by the time she was 5 or 6, she would eat nothing. And in fact, she had visceral responses. She would look at tomatoes and throw up. And it was insane. But like now she's, starting to open up again. So I'm curious, like, as we age, like, where are we seeing our pure inherent preferences? Or is this, or in childhood, are we just, totally screwed up anyway?
No, I think that, I by the way, I have the same experience at home, and it feels very frustrating for somebody who does research exactly on this, right? But there are different layers, and we always have an opportunity to grow for healthier and good preferences in our in our diets. Typically, there is a very important and sensitive window that takes place on the first year of life, first couple of years of life. And this is when exposure through flavors in breast milk and then in your first solid foods, babies start learning and being really changing their preferences as they exposure. If you only give them what they like to eat, if only feed them banana puree and the fruits that are sweet, then they will have more trouble in accepting later on as they grow things that taste bitter, right? So there is a very important window early on that they can learn to accept at least.
When is that window close?
I don't know if it closed, but it is very sensitive to learning in that first 2 years. Those are key. However, what you said is true. It happened to me too. I was so happy. My kid, by 2 years, he was eating every vegetable under earth and he was accepting everything. But then he went through a period between 2 and 5 or 6, 7 that he didn't want anything but a few things that were safe for him. And so what happened is that as they become more independent and they start moving around, and it kind of like another period that it becomes more protective. And for some people, is stronger than for others. This kind of almost like a picky eating trait that can in, which evolutionary makes sense, because imagine until like 2 years, you're very close to moms and in the secure niche. But as they start becoming more mobile and they gaining more independence, they will increase the chances to encounter things that may be toxic. And so some are more sensitive than others to that during that period in trying to avoid things that are bitter or textures that they are not familiar with. And even if you give them all the exposure in the world, you can still find that certain individuals will go through periods that they will change and start avoiding things. But the good news is that you need to keep on trying and exposure them, ask them to keep on trying, even be familiar with the flavors, so that they are likely in a familiar environment at home. Keep on asking them to eat things even if they are not their favorite, because once they experience again that positive effects of the food, they are likely to start learning again a preference and liking those things. So you can learn even as an adult new preferences, but you need to expose yourself and try be open to try and more than one time to like it.
We usually think about food, particularly in the standard American diet, that are become addictive, like anything with, high fructose corn syrup, things like that. But is there also an element of, and I have no idea if this is true, but, this idea that sometimes we are attracted to the food that maybe our bodies tend to need more? For example, inherently, I have always been personally a guy who's not a huge vegetable guy. I have to force myself to eat vegetables, right? But, it's really easy for me to eat a steak. It's very easy to... so why is there something inherent? Do our bodies direct us to certain macronutrients based on need, or is it the other way around, where our tastes ultimately will dictate what we end up eating, and it has nothing to do with what we need?
I wish there was more of a wisdom of the body. There was a time where thinking that really was a wisdom that you will guide you through eating what your body needed.
So that's just not the case. That's a pipe dream, probably.
Maybe under certain extremes of nutrition, of a certain extreme of the efficiency of something, they will come up with some particular appetite. But it's unfortunately more the case, and this is also, again, based on evolution, that our brain still responds as the brains of our ancient antecessors. And we are more likely to be influenced by our environment than we are by what our body needs. And so, again, a study that this is a study in rodents, but it applies very well to people's behavior in the supermarket, okay? So we're from our colleague Mike Tordoff, also at Monell, and he did this brilliant study where he will give to rats, for example, 3 cups, one with mostly protein, like a chow food with a lot of protein, one with a lot of fat, one with a lot of carbs.
Mm-hmm.
And it was the rat could eat from each of them and maintain all that they needed for each of these macronutrients, okay? And so he registered how much they will eat. And then he play and put animals on different situations where he gave them still these same 3 cups, so he could have a regular diet, but it add one more of fat. Or in another group, add 1 more cup of carbs in addition, or 1 more of protein. And what he found is that rodents will eat more of whatever they have more. So it's not that they were still maintaining the equilibrium of eating whatever they needed from protein, carbs, and fats, but if they were double fat in that group, they were eating much more fat than any of the other macronutrients. And if you have more of carbs, you do the same. Even more, he tried that not just with food, he tried with sugar water versus water, and more availability of sugar water. Guess what? The rats will drink more sugar water. Even with alcohol. If you take rats and you give them all the water they can drink from 1 bottle, all they need for the day, and you start giving them bottles with alcohol and water, the more bottles of alcohol he put in the cage, the more alcohol they will drink, even if they could choose to only drink water all day long. So it shows that there is this wisdom of the body of needing what you need. Was not so true, that it was more that whatever in your environment is the more available thing, the easier thing to get, that's what you ended up eating.
You just
most.
pack on as many calories as you can is ultimately sort of what it seems like we're doing.
Yes,
Animals.
but in fact, you you pack up as many as you can from the more available.
Mm.
Not necessarily all,
Got it.
you know.
Yeah, so that you adapt to wanting that maybe more or something like that.
And then, of course, again, is that it's more that you eat what you crave what you eat more than you eat what you crave. Of course, then you let's say you never eat sushi, you're not going to be craving sushi. Now, if you eat, you need to eat it to crave it and want it. So it is important. This brings us to food and, the food deserts or the availability of food that the cheapest thing you can acquire are highly fat, highly carbs, right? All this combination with high carb, high fats, and less of like fruits and vegetables is the most expensive thing you can buy.
Yeah.
Or the less likely to find it in different stores. So that is conditioning also what people are eating and liking and choosing to eat.
What can you tell us about, from a practical application or intervention standpoint? Is it possible to actively change taste perception or modify how we perceive food flavors so that we crave healthier foods?
Yes, and there is data that support the intervention that should be doing. It's just maybe not the one thing we're doing. But one very good intervention is to check on the diet of pregnant women and make sure that pregnant women eat healthier foods. So if you're treating a pregnant woman and give them more access to fruits and vegetables and healthier lean meat and so on, then that baby will also be exposed to those cues and will already have innately a better preference and go for those things. So feed pregnant women and early on kids a lot of fruits and vegetables, some healthier foods. In schools also, the peer role of like what the teachers are eating and what other kids are eating in the school have a huge role on also modeling food preferences in children. For example, in Europe, there are many countries where kids cannot bring at school, like, say, cookies and a sandwich with white bread. They had to be integral bread and no cookies allowed. And they check every school lunch. And if you brought something that is in the prohibited list, they send them back home and they cannot show to other kids. So it's a way of like exposing in the environment and giving them early experiences to healthy foods will help people choose healthier. But that's not what we live, unfortunately.
Yeah. So I guess the last question to ask is, are you or do you know anybody who is working specifically on potentially trying to intervene in people with metabolic health issues, diabetics, obese individuals? To me, it just seems like an interesting, way to intervene, and in addition to medications, pharmaceuticals, things like that. But if you get actually people to taste things differently, then that might help. As an aside, I think I've heard people on GLP-1 inhibitors actually taste things differently sometimes too. Have you heard that?
It is very interesting. I want to do research on that. And there is research, I know of protocols that are ongoing because anecdotally and based on evidence of like recapitulating on what people are saying on their experiences when they're under the effects of the GLP-1, they say that it changes. Like, they have, let's say, less cravings, so they don't feel like really, or they can satiate with much sooner, with less sugars, with less of the sweet taste, similarly to what the bariatric surgery do. Like if you think on this, the gastric bypass or sleeve gastrectomy surgery, at least the first few months after surgery, people say they don't like sweets as much, don't like fat as much. And with the surgery, a lot of things are going on and moving. But one thing that also changes is a huge response, like an exaggerated GLP-1 response when they consume sweets and fats. So maybe it's just like these agonists, like these wonder drugs that are coming now. It has an impact on how they perceive that. In particular, is that kind of like when we eat for hedonic reasons. You can eat because you're truly hungry, like after not eating for like 12 hours and you wake up in the morning hungry. But you could also eat for just pleasure, like you finish a huge meal and then they bring you dessert and you have no more appetite, but you just eat because of the hedonic value of the food, because it makes you feel good, because you crave that sweet taste or chocolate or... And so what the GLP-1 seems to be doing is really reducing your hunger for the hedonic value, just for pleasure. So you will eat, and then very quickly you said, I had enough, and I don't have desire for more. And that seems to be also what happened with these bariatric surgeries early on. And I think when you think on interventions, that window look like a precious new window to get at your new setup for a new healthy diet. If after surgery or with these GLP-1 drugs, you only eat less of what you were eating, so you just eat a smaller burger with a smaller portion of fries, you will lose weight. But when this kind of magic of the setup that you have, that you reach satiation much sooner, goes away, then you ended up slowly but slowly and getting to eat the very same thing you were eating before the intervention, the surgery or the drugs. So it will be important if we could capitalize on those windows of time where you are not truly desiring, you remove your vulnerability to the hedonic value, to eating for pleasure, and then reset to learn now to eat healthier food, to enjoy what it is, the flavor of fruits and vegetables and lean meats and some lean dairy, right? Then maybe is the chance that you can truly be able to maintain the weight that you lost by eating lower calories at the beginning and learning a new healthy diet. So this GLP-1 is really showing us not only what happened in the peripheria, like you feel your stomach takes longer to empty, so you feel like full for longer, but there are some important receptors in the brain at the central level that are also coding for satiation and for that hedonic pleasure, that if you don't, once the GLP-1 is occupying those sensors there, then you stop eating and you stop feeling like you want to eat more. So GLP-1 at the central level is also important, and these drugs are just removing your appetite for ingestive in general, anything that we eat for pleasure or drink, even alcohol.
Yeah. Fascinating stuff. Dr. Pepino, has been so nice talking to you. How do we learn more about your research if people are interested in finding out what you're doing?
Oh, thank you for that question. So we have a webpage, the Pepino Lab. So if you Google Pepino Lab UIUC, you'll find our lab, and then there is a link that you can explore some of other research we're doing. We study a lot about alcohol and the way our body handles alcohol and why people become, for example, more likely to develop an alcohol problem after bariatric surgery and so on. So different ingestive behaviors are modified by these surgeries. And I invite you to go into our webpage and ask more. There is my email there. So if you want to send me an email and ask me more individual questions, something that we covered and wasn't clear here, I'll be very happy to chat with you.
Wonderful. Thank you again.
My pleasure.